Ciao guys, it's Sam again. If you know me, you might remember that I'm at the head of the AI data engineering team in Acer in the EMEA region. And I wanted to start this new series because I do a lot of fancy things with AI. Some are niche, some are a little bit tricky, some are just fun. But I wanted to show it to the outside world because most of this stay in our premise because my job is satisfying our business customers, so developing solution for them. But I think some of this could be interesting also for you to discover what we do. And at most, you're gonna learn a thing or two or see how things get done on my side of tech. Today, as you can see from the big writing on the screen, I want to talk to you about the AI metaprompting technique that I've been using for my RAG pipeline with Sofia, which is the internal AI assistant that I developed. Now it has more than a couple of years because we started in 2023 and it was actually in production at the beginning of the subsequent year. So it has been a while. And this technique has been around for a while, but since I haven't talked with anybody yet, then it's pretty new for you. Let me explain. So Sofia is our internal AI assistant. And if you don't recognize this logo, this is the Weaviate logo. Weaviate is a vector database where I store all the embedded information that I get from the business from all kinds of data sources, OneDrive, random files, internal system, whatever. We store stuff there in order to do RAG search. The search itself is hybrid, is both with embedding, so vector distance and the BM25, but we're not talking about that right now. If you're curious, maybe you can ask for another video. What I want to talk about is how I optimize the retrieval and the token count and the accuracy actually when dealing with RAG and this internal enterprise system. So let me explain how it works. So basically, let's focus on this right now. Basically, Weaviate and others, so it's not only Weaviate, you can use whatever vector database. I just happen to use Weaviate. It's allowing to work with collections. Depending on which part on the data side you are, a collection is like a schema or is like a separate database. Matter of fact, the data in one collection are completely separate than the other collections. So you can only search one collection and the vector space that you're searching around is the vector space of that collection. So here I put some examples. Maybe I have the collection for my legal contracts, the laws, marketing commercial, the store. There are a bunch. You can imagine there are a lot of different collections because we have a lot of different departments. We are an enterprise. We have legal, marketing, the PBU, which is the product business unit. We have finance. We have the service, repair, etc. We have a bunch of collection and we have a bunch of countries. Acer EMEA is a very heterogeneous region, which has 25 different countries. So you might imagine that the HR information for Germany doesn't need to be the same and doesn't need to be accessible by the HR in Spain, in South Africa, in Italy, whatever. They are separate collection, even from the same business unit, but separate because they are different content that should not be accessed by users. For this reason, there is actually a configuration for the user access. This is actually stored in Redis. I store a lot of things in Redis. That is actually a pretty neat database, which should not be used only for caching things, but it works pretty well also for lots of other stuff. Basically, so the user can access only a subset of this information, of these collections, depending on their role and their position, etc. And this user configuration is stored in Redis. So whenever a user is asking Sofia for something related to the internal documentation, Sofia only search the collection that makes sense. For example, if this is a user from legal and he's asking for some contracts, Sofia knows, okay, this user is allowed to access this collection. Good. Between this collection, there is the legal collection. Good. He's asking for a contract. Good. Then we search inside the legal contracts collection. This allows me to reduce the number of searches, so reduce also the number of output that the AI then needs to parse. Because if I was going to query in parallel all the collection, including the useless one, maybe I will get some low relevance results, which will pollute the context and basically make me waste a bunch of money and a bunch of time. But one thing is very important is that user won't ever ask your AI agent, oh, can you please query this particular collection for me because I need this particular piece of information? You, as a developer, as an engineer, as someone that knows the system, maybe will do it and you will get exactly what you want. But the user just wants the magic. The user, it will ask, oh, get me the contract for this and this time and whatever, with a bunch of rules, and they're not going to ask what is it searching for. Basically, users want the magic of AI of asking, oh, give me this information about this contract for this person. And then they expect the AI to automatically get exactly the information they need, even if generative AI has nothing to do with searching large amounts of data. People really misunderstand it. And searching large amount of data and LLMs, it's maybe the farthest thing possible. Then you can use vector database, normal database, searching, full text, whatever, to search and have the AI sort through the reduced result set that you extract. But people imagine, oh, now AI is connected to all of my information. I can just search for all of my information. Not understanding that the AI is not really connected. It's you that created the agent, the harness, the whatever, that made this possible to work. But that's another thing. In order to solve this, I have devised this evil plan of having a two-step system prompt built exactly to optimize this process. So again, all of my information is stored on Redis, so the permission for the user, what they are able to access, etc. But I also have the so-called metaprompt information for the single collection. Because imagine you are, again, example as before, person from legal that wants to search some contracts about something. And maybe you have a specific collection for that. How is your agent supposed to know that it has to look in that specific collection? Maybe the name of the collection is clear enough, but clear enough for you, maybe it's not clear enough for a model. And maybe since it's not deterministic, clear enough one time doesn't work every time. So what I do is I have a core system prompt that defines basically the behavior of the agent. So who it is, how it talks, all kinds of information about style and behavior, and that stays static. Then each user has his own user system prompt, which is still part of the system prompt in general. And this user system prompt basically composes only the collection information that the user has actually access to. So basically, if I had a normal system prompt where I put in, the collection called legal 0206 contains all the document for legal based on this time period, etc. The collection 2 contains this and this. We cannot push all of this information in the system prompt all of the time because this will pollute. It's useless, and basically it will get a lot of useless token consumption every time in the system prompt because it's giving you information that you don't need. What I do is we inject in the user system prompt only the collection that the user has actually access to. So basically, we say this user has access to collection legal contracts and legal law. But one more thing that I do is for this collection, I create the meta prompt in order to explain to the AI which information is actually inside of this collection. Because if we just listed the collections available for the AI, we will just have a very bad security thing. By the way, security is handled deterministically. So even if for some way you're able to do a prompt injection and trying to make the AI do a query to a collection you don't have access to, it won't work because every security check is deterministic, plain old code, AI cannot get over it. So this is not for security. This is only for accuracy. Because, for example, in the legal contract, my meta prompt will be this collection contains all the information about contracts with this characteristic. Use this whenever the user is asking about contracts, for example. Of course, it will be way more specific depending on the collection data itself. But basically, this is helping the AI to get a search perimeter which is as small as possible. And that's basically the trick. So instead of having all the collection available for everybody and then relying on the deterministic user security, we dynamically tell the AI only which collection are available. And I'm doing this and I'm not using a tool to get the collection available from the user because we don't have many collections. So the amount of tokens that I'm going to use to create this list with meta prompts, it's already similar to a potential tool that I would use to get the information. But in this case, I'm able to do one less turn because in the first turn, if the user is asking me for something, immediately the AI can call the tool to do the search on the vector database. If the AI didn't know immediately, like in the system prompt as we have, which collection are available, which information, then it will need to call a tool to get this information and have it in the context, and then from there call another tool again. So for me, the price of this it's lower than that because it's true that this is here all the time, even if the user is not calling the vector database for internal knowledge, but this is part of the system prompt. These collections don't change frequently because, I mean, how many times you can update them during a day. And so all of this is basically cached for each request. So the amount of token is very low. This is part of the system prompt. The system prompt overall doesn't change per user. So this user prompt is mostly cached. And so this becomes a little bit fractionally more expensive, but you won't even notice. Then whenever the user is not calling at all the information about internal knowledge, but whenever they call the information about the internal knowledge, it's way faster and it immediately returns the data because it already knows where and what to get in order to get that result. So I hope I was clear because this was completely unscripted. I just wrote in Excalibur a bunch of arrows and squares and whatever. If it's not clear, please go into the comment section and tell me whatever I did wrong and I can explain it a little bit more. And talk to you soon with another neat feature from the internals. Thank you.